teach you about the ignition system, and it is just a short episode of around 15 to 20 minutes, whereby, as you can see, I've already projected to you the electronic ignition system construction and operation. Among other things, we'll be able to touch on this topic for a very short time. And the types of electronic ignition systems that we have so far, we can be able to magnify that for you so that you can see, will be as follows. But by the end of this lesson, the students will be able to learn about the various types of ignition systems. I'm going to explain the operation principles of ignition systems, the construction of various components of the ignition system, and then from there you're going to follow up and now describe the rest, because this is just the mechanical one, the oldest, the ignition system. The rest are, in fact, another name they give this one is catering, and then the rest is catering is this one. So catering is just the difference between this is just the spelling pronunciation and handwriting. Okay? For ignition system. So, but it means the same thing and the way they want to. But now the rest of the other systems you are going to learn is that you learn the rest for the rest, but then now not for the coil. Now you're going to learn the rest for what you call now 2, the magneto, which you can see here. And then 3, you're going to learn for what you call the transistor assisted ignition system. And then 4, you're going to learn about the electronic ignition system, which is just stands for its own. And then the CDI, which is the capacitor ignition system. So the operating principles of the ignition system, starting with the coil, I might not discuss this as I have stated, but basically I want to inform you that this is the oldest type we have that was brought up by the first person who made up the engine, called the Ottoman, who came up with what you call the four-stroke engine. The Ottoman, if you see a diagram on this other side, you will see this is the Otto cycle. Okay? What do I mean by the Otto cycle? The Otto cycle is a name of a person who was the first person to make the first engine in this world. He's not alive at the moment, but this gentleman came up with the four-stroke engine, which talks about, this is the intake, then we have the compression, okay, and then we have the exhaust, compression, intercompression power, and the exhaust. So, intake is when the fuel comes in through the intake valve, okay, to the combustion chamber, which is called the CC. Okay, and then you find that the piston is moving from the top dead center to the top dead center to the bottom dead center. Then on the next step, which is now the compression, the piston will be moving upwards. That's from the bottom dead center to the top dead center. Then when you come to the power, you find that the piston will be moving downwards, because at that point you find that the intake and the compression valve are closed. And then the fuel and the air that came in has been burned. Now it's going to be pushed down at this time from TDC to BDC. Then we have the exhaust, whereby the intake valve will be closed and the exhaust valve will be open. So all the gases will be getting out through the exhaust pipe, okay? Then be getting out through the exhaust pipe. So that is what gives you what we call ICPE. That is the secret, intake, compression, power, and exhaust. So back to what we are learning today is all these systems depends on which type of system you are using. But then the basic one, which is the coil ignition system, which is just basically the coil ignition system, which is just the basic one, which we have so far. It has the construction of that. It's basically what you're seeing on the board. Whereby we have a distributor here, which is a trigger of current that is going to be distributed through a system whereby we have the ignition stop switch, which is the ignition switch, and then through the diodes, which will allow current to pass through only one direction, and then coming in through the capacitor here. And then a capacitor is a component that can be able to store some energy. Then we come to the ignition coil here that is going to produce 12 volts power from the battery to almost 20 to 30,000 volts, which is going to come to the spark plugs. So what are the spark plugs? The spark plugs are these ones. Okay? Spark plug number 1, number 2, number 3, number 4. So when they are like that, they give you this order. This order is not the order that is here. So this one is called firing order. So the firing order is 1342 or 1432, whichever comes first, or depending on the manufacturer's specification. It will mean that when this power, if I can give you another clear drawing, when this power comes in through, this one is now clearer. Let me give you this drawing now here. So if I talk about power coming in from how the ignition system works, we may say that this is 1, 2, 3, 4, they are well arranged, fine. But how does it operate? This gives you a pictorial diagram of a distributor. And this gives you the inside part of the distributor, whereby we have the condenser, we have the contact points, and the vacuum advanced unit here. Then you have here the coil. So this coil is this one. So this coil is the one that now will bring in power to this spark plug of 20,000 to 30,000 volts. And then now this power is going to go to each cylinder. But the power that was produced here was only 12 volts. So you can imagine what is going to happen is that you are going to need now to do what you call now, you have to do what you call ignition timing, so that you can have this timing, right? This timing so that you cannot have problems when you're starting your vehicle. And the timing goes according to this. So the first cable, which is the HT cable, will come to here, number 1, spark plug number 1. The next one, if you're using this timing, the next cable on the distributor, the second one, will come to number 3. On the distributor, then the third cable is going to come to number 4. Then from the distributor, you pick the fourth cable to come to number 2. If you're using this firing order. If you're using this firing order, then the first cable from the distributor, the first cable, you know there are 1, 2, 3, 4. So this is cable 1, this is 2, 3, 4, because the distributor rotates at a clockwise direction. So then now, we're going to pick this, if you're using this firing order, cable number 1, which is this one, you bring it to here. You take it to, like let's say this is number 1, you take it to number 1. So if it's number 2, if it's 4, on this side of the engine, which is that one, so you'll be able to take the second one, which is this one, to number 4. But they are brought it to number 3. Okay? So number 3 meaning they are using this firing order. Okay? And then the next one, which is this one, they are taken to 4. Okay? And then the last one here now, they have taken it to piston number 2, which is the last one here as well, piston number 2. Because this distributor is rotating at what we call at twice the crankshaft speed. And that is what is giving us that firing order. So straight away, let me go very, very fast to what we need to learn today. And then we can be able to finish up on that. So let's have the types described here: electronic described, or magneto described, transistor assisted described, the capacitor CDI described, the distributor described as follows. The electronic ignition system, as shown on the board, you can have a look at what is on the board. We have these systems being the same, but there is an addition of what? Can you see this? An amplifier. And that's the difference we're going to have, the ignition systems. So if you have the first drawing right on your fingertips, then the rest is no problem. So the rest you have to know what is the difference from this ignition system to the other, and what makes it what it is. What is the construction operation and that. So if you see, it has the battery, it has the ignition kit, it has the coil, it has the distributor, and the spark plugs, just like the other one. But the difference now here is what we're seeing there. It has got an amplifier there and a fast generator. So the electronic ignition system, from what is on the board, you can see, let us read together. This is an electronic ignition system type that uses the transistor. That is the difference with this to make what you call an electric circuit work. So a sensor controls the transistor to create the electrical pulse, generating high voltage spark that can burn the real mixture and provide what you call better economy and low emissions to the environment. The role of the electronic ignition system remains the same because, as I have just said, everything is the same because it generates what you call high voltage spark to ignite the air fuel mixture to the spark plugs, as we saw before. So why electric? Why should we do that? Why? We should do that because of the following things. One, limitations of conventional are that it's too mechanical. That's why we went to electrical. Because sometimes it's prone to breakdowns, sometimes contact breaker points have they cannot be able to handle it. They have to handle a lot of heavy current. Have you seen that? So that's why mechanical is not really the best. So when you come to electronic, it can handle heavy currents. Mechanically driven contact breaker points, sometimes they have inertia effects. So high speed, sometimes they affect it. Okay, number two. Number three, the coil has less time to build up, okay, to the current to maximize the value of the higher speeds that the electronic system can be able to manage. So components of the electronic ignition system are as follows. That's the battery, the armature. If I can magnify that for you, the battery, the armature, the ignition switch, the electronic control unit. At least we can see there is a difference. Okay, so you must put it there when you are drawing. Show the difference. The ignition coil, the ignition distributor, the spark plugs, and the rest. And from that drawing that you can see here, you can have one of the electronic ignition system shown. So this is what basically I always need, and I don't always want you to draw the diagram exactly the way it is. You can just make it, you can just draw what you call a block diagram, provided you get inside what it is. So here we have the battery, the first one. This is the earth. Then it brings into the ignition switch. We have the electronic control unit, then the ignition coil, then the distributor, then the spark plugs. But this magnetic pickup we have here, it is an expansion of what we are having here from the electronic control unit, which is a combination of the two. We have the magnetic pickup, which is purely electronic, and the ECU is to communicate under what we call a closed loop system, whereby the information it sends, it has to come back again, then the information again is sent back again for a reaction to take place. So when we move on, you can be able to see what you call the battery described in detail. You know, the work of the battery is to produce power. The armature, you know, usually it used to generate the magnetic field in the system. And then we have also the ignition switch, which is used to just produce what you call a contact, point of contact. The electronic control module is just there to be able to communicate for you and do everything for you electronically. The ignition coil is also a very major important component that can be able to give you from 12 volts battery produced from the battery. It can be able to produce for you up to 20,000 to 30,000 volts.
Check. So it acts like a transformer.
Then it's a transformer. Yeah, it boosts out the current. Okay, so that's what you call the transformer, and it is been indicated here. If you check on here, they are talking about a stepper. Okay, and then we have what you call the ignition distributor here, which distributes the current to the spark plugs. As you can see that, just the spark plug is the last point of delivery of this current to the CC, the combustion chamber. So the operation, this is what I will need you to do. This is what I needed you to do. I needed you to do what you call the construction. the operation with a drawing. That is, everything is done. So you have already the construction operation and of the ignition system. So finishing up on this operation, there is a figure that I have just shown you that is a bit simplified. And on this figure, you'll be able to see that we have, I want to describe a bit the operation of it, whereby a timer is employed in the distributor of the electronic ignition system. So the timer usually sends the electrical pulses to an electric control unit. That's how you say it. And which switches off the flow of current to the primary winding. I don't need you to copy paste this, I need you to understand it. Then from there it sends the results. High voltage is induced in the secondary winding, which is then distributed to the spark plugs in case of a breaker point ignition system. But now the electronic control unit later switches on the flow of the current to the primary circuit, so that the primary circuit can build up for the next cycle. So the timer is the one which can be either pulse or it can be Hall effect. We have two types of timer there. Other than this, the electronic ignition system works similarly to the conventional type. The only difference is that this one has got an ECU and such like. So what are some of the applications where this one is used? They are used mostly on these modern vehicles, hypercars. These are the rally cars. That's the examples of the Audi, the Mahindra, the XUVs and the rest. We have also what is used on air cars. You know, when you're in the technology world, you have to learn about all this. What are the advantages? You know, the advantages are more than for the mechanical, because one, they have more long maintenance systems compared to the coil ignition system. Number two, it has no moving parts because it's controlled by the ECU. Number three, it has no moving parts. Emission is less, increases efficiency, it's more accurate, and the vehicle has long time of service. And there's nothing in this world that doesn't have a disadvantage to finish with. The main disadvantage of the electronic ignition system is that it's very, very, very expensive. Very expensive to afford on vehicles having an electronic ignition system, but it is the nature of the best. So for that short